Son of a beach, that was fun. Find all integers x, such that 8 to the x minus 2 to the x divided by 6 to the x minus 3 to the x equals 2. We can start out by making a guess, perhaps trying x equals 0. 8 to the 0 minus 2 to the 0 over 6 to the 0 minus 3 to the 0, does that equal 2? Unfortunately, on the left-hand side of this equation, when we plug in 0, we get an indeterminate form. 0 over 0 does definitely not equal 2. So x equals 0 is not a solution. Now we're going to note that 2 to the third power is equal to 8, and we can also write 6 as 2 times 3. So we're going to rewrite our expression 8 to the x power as 2 to the 3x power. And we'll split up 6 to the x power as 2 to the x times 3 to the x. Now, where we go from here is we'll factor a 2 to the x out of the numerator and a 3 to the x out of the denominator. And because the top part, the numerator in the parentheses, that factor is a difference of two perfect squares, we can factor it as such. A squared minus b squared equals a plus b times a minus b. So we now get two factors of 2 to the x minus 1 to cancel, and so now our expression becomes simpler. We can write it as 2 to the x times 2 to the x plus 1 equals 3 to the x times 2. Or 2 to the x minus 1 times 2 to the x plus 1 equals 3 to the x. Now what about x equals 1? If we plugged in x equals 1, we get 2 to the 0 times 2 to the first plus 1 equals 3 to the first. That actually checks out as an answer. So at least we found one solution here, x equals 1. Now let's consider all the solutions that might be greater than 1. And what we're going to show here is that there are no possible x values greater than 1 that can work in this equation. So if x is greater than 1, x minus 1 is positive. And 2 raised to the x minus 1 power multiplied by 2 to the x plus 1 equals 3 to the x power allows us to make this analysis. The first part there is going to be an even number, the second part there an odd number, and on the other side of the equation, an odd number. This happens to lead to a contradiction because an even number multiplied with an odd number always works out to be an even number, and an even number is never equal to an odd number. So therefore, no x values greater than 1 are possible. But since x can be any integer, we also have to think about negative numbers. So let's let x equal a negative number, negative n, where n is greater than or equal to 1. Plugging this into our equation and simplifying some of the results here, we get 1 over 2 to the n plus 1 power multiplied by 1 over 2 to the n plus 1 is equal to 1 over 3 to the n. Now we can clean some things up here using the rules of exponents. So on the left-hand side of our equation, we'll get 2 to the n plus 1 over 2 raised to the 2n plus 1 is equal to 1 over 3 to the n. And rearranging this, we can show that on the right-hand side, we'll always have an even number. On the left-hand side, we get the product of two odd numbers, which is also an odd number. And again, a contradiction ensues. An odd number is never equal to an even number. So we can't have any negative integers working as solutions. Therefore, x equals 1 is our only solution. I hope you enjoyed this video. Please hit that like, subscribe, and notification bell for more videos, and stay tuned for the next.